Good morning, this is Ms. Parks, and today we're going to do the sum and difference identities for sine and tangent. We already did them for cosine. Sine is almost identical to cosine, is a slightly different formula, as you can see right here. Tangent can be a little bit daunting, but for tangent, the thing that I want to mention is to not use the 30-degree reference angles. So 30, 150, 210, and 330. Don't use these. So instead, we want to use 45, 60 in the first quadrant. Second quadrant, 120 and 135. Third quadrant, 225 and 240. And in the fourth quadrant, 300 and 315. So these ones are okay. These will work, but what will happen is that because tangent at those angles is a fraction, then you're going to have a fraction within another fraction, and it'll be way more difficult to figure out. Not only are we going to have fractions, but we're going to have radicals, and if you have a fraction with a radical and then the radicals in the denominator, this will be way more difficult, and so stay away from those. You can do every other angle without using those and just using these numbers, so that's what we're going to do. Okay. So here we go. All right, so let's start. For sine of 75, you can probably already figure out what it is. And that will be sine of 45 plus 30 or 30 plus 45, whichever way you want to look at it. So for the sine, it's slightly different than the cosine function, or cosine identity, excuse me. However, the answers will all come out the same, which is the same at cosine was always radical 2 over 4 or radical 6 over 4, although the signs change. So here we go. This one goes sine of 45, sine of 30, sine of 45, cosine of 30, plus cosine of 45, sine of 30. All right, so this is radical 2 over 2. You guys should know. Go ahead and finish the rest. Pause the video, finish the rest, and see what you get. All right. Radical 3 over 2 plus radical 2 over 2 times 1/2. Radical 6 over 4, radical 2 over 4. That should look familiar. This is slightly different because cosine was cosine, cosine, and then sine, sine, and then the signs, these signs were different, and here they're the same. All right, for tangent. So tangent is going to be a little bit more detailed. However, it will also be the same for every tangent question, or very similar. So once you do one, you should be know what to expect for the next one. All right, so if I multiply this by 180 over pi, this comes out to be tangent of 105. So again, we don't want to use any of the 30-degree reference angles, so I'm going to use 60 plus 45. All right, so for the tangent of 60 plus 45, we're using this. Okay, so tangent A plus tangent B. So tangent of 60 plus tangent of 45. On the bottom, it's 1 minus these two multiplied together. So tangent of 60 times tangent of 45. Tangent of 60 is radical 3. Tangent of 45 is 1. This is 1 minus, and then this is tangent of 60 times tangent of 41, or 45, excuse me. So it's 1 minus radical 3 times 1. So this is 1 minus radical 3. And so this will always be the case. So you're either going to have 1 plus radical 3 on the bottom or 1 minus radical 3 on the bottom. That's it. One of those two things. At the top, you're either going to have radical 3 plus 1 or 1 plus radical 3. There really aren't any other choices because we're not using the 30-degree reference angles. If we were, then we'd have like a radical 3 over radical over 3 on the top or bottom. So for the most part, you're always going to get to this point, and then you're going to get rid of the denominator, the radical down here, by multiplying by the conjugate. So once we're here, the rest of it is just simplifying. Okay, so we're going to multiply top and bottom, use parentheses, by the conjugate of the bottom. And we're going to do this for all the tangent problems, and you're going to become familiar with it, and it's going to become easier and easier and easier. All right, so at the bottom, because they're conjugates, you're going to have 1 minus 3. And that will always be the case, because even if you have 1 plus radical 3, then you'll multiply by 1 minus. So the denominator after this step will always be 1 minus 3, or negative 2. At the top, we're going to have to distribute. Okay, so we're going to take the radical 3 times both of these. So radical 3 plus 3. And then the second part will be 1 times both of those. So if I do 1 times both of these, it's going to be plus 1 and then plus radical 3. And that, the top, you're going to have 4 plus 2 radical 3. And at the bottom, you're going to have negative 2. And again, at the top, you're always going to have two numbers that add together to 4 or negative 4. And you're going to have two radicals, and those will be the same sign. They're either going to both be positive or both be negative. So you're either going to have plus 2 radical 3 or minus 2 radical 3. Then, for the final step of the tangent, you will reduce, and they will always reduce. So think of this as 4 over negative 2 plus 2 radical 3 over negative 2. So when you reduce that, you're going to get negative 2 minus radical 3. So every tangent question will be this answer. It's like every sine and cosine question will be that answer, with the exception of whatever signs they are. So it could be negative 2 plus radical 3, it could be 2 plus radical 3, and it could be 2 minus radical 3. These are your 4 choices. All right. All right, so that's your final answer for the tangent one. Let's see what we have here. So we have this for sine of 75. For tangent of 105, we have this. And I know I didn't leave a lot of room here, but this doesn't require very much room. So we're just going to match that up with this. So this is A, and this is B. This is A, and this is B. So it's going to give you sine of 40 minus 160. I don't have room. So that'll be sine of negative 120. And sine of negative 120 with a negative angle identity is the same thing as negative sine of positive 120, or the sine of 240, either way. And so you're going to get negative radical 3 over 2 for your final answer there. All right, so on the negative 120, you can either use a negative angle identity, or you can just go to negative 120, which is here. And sine would be negative radical 3 over 2, because sine is the y value. All right. All right, your turn. So pause the video, try all 3 of those. Your answers or the angles that you use might be different than mine, but your answer should be the same. Pick whatever angles you want to use. Just make sure for tangent you don't pick you don't pick 30, 150, 210, or 330. All right. All right, you should have done all 3 of those by now. So here we go. I'm going to use here sine of 30 minus 45. This will give me sine of 30 cosine of 45 minus cosine of 30 sine of 45. So sine of 30 cosine of 45 minus cosine of 30 sine of 45. And that will give me radical 2 over 4 minus, let me make that 3 better here, radical 6 over 4. For the second one, tangent of, and then I'm going to multiply this by 180 over pi, so that will give me tangent of 195. I'm going to use tangent of 60 plus 135. So that's going to give me tangent of 60 plus tangent of 135 divided by 1 minus of the top for tangent. If this one's plus, this one will be minus, okay? So minus tangent of 60 times tangent of 135. I'm going to leave room over there, so I'm going to go this way. Tangent of 60. Tangent of 135 is negative 1. On the bottom, I'm going to have 1 minus radical 3 times negative 1. So that'll be radical 3 minus 1 and 1 plus radical 3 at the bottom. So we're going to fix that. Don't forget your negatives. This is multiplication here. You're not going to have 3 terms. So it's always going to be a binomial at the top and a binomial at the bottom. So if you have more than that, something's wrong. All right. And it's always going to be 1 plus radical 3 or 1 minus radical 3 at the bottom. So we're going to multiply by the conjugate. Put parentheses around the top for multiplication. So at the bottom, 1 minus 3. At the top, we're going to do radical 3 times 1. Radical 3 times minus radical 3. And then negative 1 times 1. And negative 1 times negative radical 3. If I add those together at the top, I'm going to get negative 4 plus 2 radical 3 over negative 2. And then if you divide everything by negative 2, you're going to get 2 minus radical 3. And that's this answer. First one was that. So if you didn't get that, just kind of check the signs that you use for tangent and make sure they're, if you're in quadrant 2, that would be negative 1. Okay. For this one, this is A. That's B. Again, that's plus and that's minus means it follows the correct identity pattern function. So that will give you 100 minus 70 because it always follows that sign. So that'll give you tangent of 30, which is radical 3 over 3. It's the fraction. All right, moving on. Let's go ahead and do the next ones. These are pretty easy in my opinion because you're just plugging in numbers. They're on the x or the y axis, and then usually you can reduce them. All right, so here we go. So sine of 30 cosine of theta plus cosine of 30 sine of theta. So sine of 30 is 1/2 times cosine theta. Cosine of 30 is radical 3 over 2 times sine of theta. And really, if you want, you could just leave your answer like that. You could write it, you need not like that, you're going to have to simplify it a little. So maybe radical 3 sine theta over 2. You can't combine them because these two are different. Well, you can combine them, but you have to keep them separate from each other because they do have the same denominator. So either one of these two answers is fine. So you can leave your answer like this or like this. Okay, whichever one you prefer. I'm going to do the first 3 so that you guys can do the next 3. So this one will be tangent of 45 minus tangent theta. In the denominator, 1 minus, or 1 plus, excuse me, tangent of 45, tangent theta. So at the top, I have 1 minus tangent theta. And at the bottom, I have 1 plus tangent theta because that's a 1. That's all you can do. You don't need to simplify anything here. There's no radicals. There's no canceling because remember, if you have any adding or subtracting, that's one thing, and they're different, so they cannot be canceled. For this one, sine of 180, cosine theta minus cosine of 180, sine theta. Sine of 180 is 0. Cosine of 180 is negative 1. So this is 0 plus sine theta, so that's sine theta. All right, so that's what happens when you try to write a function as an expression when we have theta and then one of the numbers on either the x or the y-axis usually. Okay, you guys go ahead and try the next three, please. Okay, so you should have finished these three examples. I'm going to go over them now, and then you can check your answers. All right. So for the first one, you should have sine of 120, cosine of theta, plus cosine of 120, sine of theta. Sine of 120 is radical 3 over 2. Cosine of 120 is negative 1/2. So radical 3 cosine theta over 2 minus sine theta over 2. Don't put minus 1 sine theta. We don't need to use 1 as a coefficient. For the second one, you should have tangent theta plus tangent of 3 pi over 1 minus tangent theta times tangent of 3 pi. 3 pi is 1, 2, 3. It's the same thing as 1 pi. It's the same thing as 180. So this is going to be tangent theta plus 0 over 1 minus tangent theta times 0. So at the top, I have tangent theta. At the bottom, I have 1 minus 0. So that's tangent theta over 1, which is just tangent theta. All right. And then for the last one here, or for number 3 that you should have finished, sine theta cosine of 270 minus cosine of minus cosine theta sine of 270. So this will be sine theta times 0 minus cosine theta times negative 1. So 0 plus cosine theta, which is cosine theta. So it's just a matter of being able to use the tools that are available to you to manipulate equations and simplify them and apply stuff that you know from the unit circle, all the identities that we're learning, and trying to simplify the problem as much as possible. For the next one, they should look familiar, slightly different types of questions, but they should look familiar to you because we did some of these. Well, let me show you how to do this. All right, so we have some formulas. So the first thing I want you to do is to actually write the identity out. So sine of A, cosine of B, cosine of A, sine of B. Okay, let me explain. So for A, I'm going to use red. Sine of A is 4/5. That should let you know that there's going to be a 5 at the bottom of cosine A because sine and cosine have the same. This right here is telling you that A is in quadrant pi over 2 to pi, so that's quadrant 2. So A is in quadrant 2, and it's 4/5, which by now you should know that x would be negative 3, so cosine of A is negative 3/5. Okay? Now, we have A finished, really. For the next part, I'm going to use blue. Cosine of B is negative 5/13. This means that B is between pi and I don't have enough room really. So let me do this over here. Sorry. A is in quadrant 2. This is A. 4, 5, and negative 3. And for B, B is in quadrant 3 because it goes from pi to 3 pi over 2. Okay, and it's negative 5/13. And if you do Pythagorean theorem here, 25 plus y squared equals 169, y squared equals 144. So this is negative 12 for the y part. So sine is negative 12/13. All right, so this is A, and this is B. All right, so that's important. And then this will be an easy question. You don't really need a lot of room. I'll explain that in a minute. So let's go ahead and finish the first one. So we have negative 20 over 65 plus positive 36 over 65. And again, don't reduce this. We want to leave the 65 on the bottom. So our answer is 16 over 65, and this is sine of A plus B. And I want to write that down there because it's going to be important when we go to do the last question over there. Okay, question 3. All right, for tangent, we have tangent of, I'm going to write the formula here, tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. All right, so tangent of A, remember tangent is the slope, so it's y over x, so it's 4 over negative 3, so it's negative 4/3 plus tangent of B, and tangent of B is y over x, negative 12 over negative 5, so it's 12/5. In the denominator, I have 1 minus negative 4/3 times positive 12/5. So we use the same exact two numbers. So this looks like a mess, but it's going to actually simplify out pretty easily. Okay, so we're going to just multiply these by each other. So not multiply, but make the denominators 15 basically. Okay, so if the denominators here were 15, I would get negative 20 plus 36. And then at the denominator, it would be 15, right? So here, multiply by 5 over 5. That's negative 20 over 15. Multiply by 3 over 3, so that's 36 over 15. Here in the denominator, I know that the denominator is going to be 15, and that's what I want it to be, okay? So this is going to be 15 over 15, the 1. And this is going to be 48 over 15. Because we have two negatives there, this is going to be plus. So now I have 16 over 15 divided by 63 over 15. And since the top and bottom have the same denominator, those can cancel. So what I have is tangent of A plus B is equal to 16 over 63. If you want, you can flip and multiply this to the top. So you could take 16 over 15 times the reciprocal of the bottom. Those would cancel. All right. So what is question 3 asking? Let me explain. So for sine of A plus B, so if I take A and B, so I know A is in quadrant 2 and B is in quadrant 3, but I don't know what the angles are. I don't know if they're 120 or 150. I don't know if this one's 210 or 240, but I do know that A is in quadrant 2 and B is in quadrant 3. If I add those together, I need to figure out what quadrant A plus B is in. The easiest thing to do is that the sine of A plus B, so the sum of the two angles, sine is positive, okay? The sum of the two angles for tangent is also positive. So there's only one quadrant where both sine and cosine, or excuse me, both sine and tangent are positive. Okay, so this one's positive, 16 over 65. This one's positive, 16 over 63. And because they're both positive, that means that if I added A plus B, we would end up in quadrant 1. So if this was maybe 150, for the first one. We can actually figure out that angle, by the way. And let's say this angle was, think about it. How could you figure out that angle? Okay. You would use inverse, by the way. You would figure out this angle, and then you would know how far away it is from the x-axis, and then you could figure out that angle. But anyway, if you added, let's say, I'm just going to put a guess up there, 150, and then let's say this one was 240, and then we've got 0, 9, 390. If I added A plus B together, and we went 390, we would be in quadrant 1. It's not 390. I'm making up those numbers, but basically that's what they're saying. The number for A in quadrant 2 and the angle for B in quadrant 3 added together would put us for A plus B in quadrant 1. All right, you guys try the next 3 problems. I probably talked a little bit too much there. So go ahead and do the next 3. They're very similar. Pause the video. All right, you should be done now. Let me go ahead and do these with you. All right, I'm going to write the formulas first. Sine of A, cosine of B, cosine of A, sine of B. I'm actually going to write the formula for tangent as well. Tangent of A minus tangent of B over 1 minus, or plus, excuse me, tangent of A, tangent of B, because the top and bottom signs are opposite of each other. And then we'll do that after. So cosine A, we're in quadrant pi, the 3 pi over 2. So this is quadrant 3. And that's negative 7 over 25. And I'm going to call this A. Please label them. For B, we're in quadrant 4 from 3 pi over 2 to 2 pi. And sine is negative 3/5. That means that that's a 4. Here, if you work this out, we have 49 plus y squared equals 625. All right, so y squared equals 576 and y equals 24. It's negative. So now let's fill everything in that we know over here. So for sine of A, it's negative 24 over 25. Cosine of A is negative 7 over 25, because that was given. Sine of B is negative 3/5. And then cosine is 4/5. And this is a minus sign right here. So if I did the work here, I would have negative 96 over 125 minus 21 over 125. So sine of A minus B is equal to negative 117 over 125. This is what we're looking for. Okay? So for A minus B, I know sine is negative. Why? Because that's what I got. A negative answer. So now I'm going to do tangent. So tangent of A is 24 over 7 minus tangent of B, which is a negative 3/4. In the denominator, I'm going to have 1 plus 24 over 7 times negative 3/4. All right, so here, this is going to become plus. So 4 times 24 is 96. 7 times 3 is 21. And then 7 times 4 is 28. Again, we're just multiplying this by 4 over 4 and this by 7 over 7. Okay? And let me move this up a little bit because it's not really where it should be. All right, in the denominator, I'm going to make the denominators 28. So 28 over 28. And then if I multiply 24 times -3, I'm going to have -72 over 28. So that'll give me 117 over 28 over -44 over 28. The denominators of each are the same, so you're going to get tangent of a minus b is equal to -117 over 44. So now we have our two answers, right? We have tangent and we have sine. In this case, we're doing a minus b, so we're saying an angle in quadrant 3 minus an angle in quadrant 4. Okay, so angle that's like 200 and something most likely. I mean, it could be 185. But an angle that's 200 and something minus an angle that's 300 and something, it's probably going to give us -100, right? If you kind of think of something 200 minus 300. However, here's how we could do it. Sine is negative, or sine of a minus b is negative. Tangent of a minus b is also negative. And the quadrant where sine and tangent are both negative is in quadrant 4. And that kind of makes sense again, right? 200 minus 300. So angle A, angle B would be about -100, which would be right there. All right. For the last question, we'll just do this one together. We'll set it up. So we're going to be using the sine and the cosine identities. So write out the sine identity for this. It's going to be pretty long. Write out the cosine identity for this and see if you can figure out how both sides are equal. So we're going to leave this side alone for now. Okay? You guys do that first, and then you can follow along with me afterward. All right, I'll do this in red. So this will be sine of pi over 6 cosine theta plus cosine of pi over 6 sine theta plus, then we're going to do this part. This is the cosine identity, so hopefully you remember what that is. Cosine of pi over 3 cosine theta, and then because that's a plus, this will be a minus sine of pi over 3. Hopefully you have your identities page in front of you. Sine of theta, and that equals cosine of theta on this side. Now pi over 6 and pi over 3, those are just your 30 and your 60 degree reference angles, right? So pi over 6 is 30 degrees, and pi over 3 is 60 degrees. You just have to make sure you just divide that into 180. All right, so what we have next, finish it if you haven't finished it already because you weren't sure what to do. Go ahead and finish it from this point forward. All right, here we go. Sine of pi over 6 is 1/2, so I have 1/2 cosine theta plus radical 3 over 2 sine theta plus 1/2 cosine theta minus radical 3 over 2 sine theta equals cosine theta. Now, we're trying to get this to equal cosine theta. We're doing a verifying of an identity. So if I add these two together, 1/2 cosine plus 1/2 cosine, that gives me cosine theta. These two, this is positive radical 3 over 2 sine theta. This is minus radical 3 over 2 sine theta. So those two will cancel out. So cosine theta equals cosine theta. And we're done. So that covers section 5.4. Again, we will be practicing this and these types of questions a lot in homework. And then we'll also do a practice quiz that kind of covers 5.3 and 5.4.